Okay, here's the code I did. For the factorial, I tested if it's 0, then otherwise I move. If it is 0, I move to just put 1 where R6 was, because that's the standard value for factorial. And then you move R6 to R5 because that's the one you're going to be working with. And then you decrement R5 because that's the next number in the factorial. Then you keep multiplying it and decrementing R5 until you hit 0, because after 0 then it would erase the value. Then you pop back, then you jump, after you hit 0, you jump down the terminal, which pops back R5, and then you return. Okay, and for the summation, you need to call the factorial, then you shift right to shift left to double it. Then you add it to R8, which is accumulating the value. You decrement R5, which is the current iteration of the summation, and if it becomes negative because you still do I sub 0, you jump down to calc done, and you move R8 to R5, and then you finish the F calc by first putting R5 to R7, then rotate left, do again to quadruple it. You add 27, then you divide by 2 by shifting right. Then you move R7 to R5. Okay, that's how the code works. So let's go through the loops. I forget to put the loop there. Okay. Okay, for a value of 5 for A, it comes out to 629, which is the expected value. Now let's do 6. Okay, step over to the end, and R5 becomes 3,509, which again is the expected value. Now let's do 6. It's -7, which breaks it because 7 is too high for the memory allocation. When you quadruple X, it goes over 32,768, which is the max volume for a signed integer on that. So let's go put -7. And the absolute value of a negative number is provided by the lab, so that's not something I have to handle. And you can see it's 56,437, which is not the expected value of -7. Okay, and that's about it. I explained why it's capped at 6, and 7 breaks it. So that's the walkthrough.